Every time you ask an AI a question, somewhere a machine the size of a building wakes up to answer it. And lately, we've been asking a lot of questions. Hello and welcome to Tech How, the place where we'll break down the tech that everybody is talking about in words that make sense. Today's topic, data centers, but not the one that you think you know, because AI is actually rebuilding it from the ground up. Let's dive into it. So first, why the sudden boom? 3 reasons. Reason 1, computing power is now an economic engine. Studies suggest every $1 invested in computing power drives around $4 of economic output, powering everything from smart factories to autonomous vehicles. Reason 2, AI demand exploded overnight. Globally, the token consumption now has reached 200 to 300 trillion tokens per day, and meeting that needs requires hundreds of thousands of GPUs running around the clock. Reason number 3, and this is the biggest one for infrastructure. Those GPUs run hot and hungry. A traditional internet data center rack used around 10 kilowatts. An AI rack today can pull 40 to 70. That's more than a 6-fold jump in power packed into the same footprint. And here's the catch. The old data centers simply weren't designed or built for that kind of heat and density. Which brings us to a brand new category. You have probably heard the term IDC, Internet Data Center. The new buzzword is AIDC, or simply AI factory. So what's actually different? Think of it this way. A traditional IDC is like a general warehouse for the digital economy. It stores websites, apps, email, and files, and keeps them online. An AIDC is more like a specialized factory, purpose-built to mass-produce one thing: AI computing power for training and running models. So the differences show up everywhere. In workloads, chips, power, cooling, and the way they are built. So an AIDC isn't just a bigger data center. It's a different machine. Higher density, hotter, and needs to get built quickly. And that changes the whole picture of building data centers. Building a data center the traditional way is slow. Survey, design, civil works, equipment, debugging, testing, step after step, on-site. One operator project took roughly 1 to 2 years to deliver a general-scale data center. It's also power-hungry and expensive to run. Across a data center's 10-year total cost, electricity alone can be the single biggest line item. In the AI era, that bill only gets bigger. So the question becomes, how can we build an AI-ready data center that is fast to deploy, efficient to run, and easy to expand? That's exactly what prefabricated modular DCs are designed to solve. Here at FiberHome, our answer is to stop building DCs like buildings and start building them like products. Instead of doing everything on-site, we turn them into standard modules: IT, cooling, power, monitoring. Pre-built and pre-test in the factory. The site work becomes assembly, not construction, just like a set of Lego. Modular data centers, or MDC, turns standard rooms into ready-to-go, high-density modules, supporting up to 200 kilowatts of IT per module to Tier 3 grade reliability. As for container data center, or CDC, which is a complete data center prefabricated inside a 40-foot container, power, cooling, cabinets, fire, protection, all inside. None of this works without rethinking power. Traditionally, the power chain is built piece by piece. Transformer, switchgear, UPS, taking lots of space and time. The integrated power module combines those into one factory-built block. Pair it with a smart bus bar that is hot pluggable and monitored in real time. This way you can add capacity online without taking the data center down. So why does going modular actually matters? 3 factors tell the story: delivery time, floor space, investment. Faster to deploy, smaller footprint, and lower cost to start. Bottom line, AI changed the whole picture. PMDC changed how fast we can build one. So instead of waiting on a construction schedule, you can ride the AI wave. But we have skipped the hottest part of the story. Literally. All those dense AI racks generate serious heat. Air cooling alone can't keep up anymore. So in the next episode, we're gonna go deep on cooling, liquid cooling, and how it can help us break the power wall. If you learned something, hit the subscribe button so you don't miss part 2 on Tech How. See you next time.